Good morning and welcome to session 9 of Virtual OTEC 2020. This session's title is Using Technology for Public Involvement, and the moderator of this section will be Jacque Annarino. I'm Victoria Beal with the LTAP Center, and I'll be your technical support behind the scenes. A few housekeeping items before I turn things over to Jacque. First off, questions are going to be accepted throughout the session in the question box. We'd like for you to please look for the question box in the GoToWebinar panel and drop a hi or hello in there if you haven't already used the question box so that we know you found it. Please note that we will not be accepting questions through the raised hand feature because there are too many participants for us to use that feature during this session. Also, there are handouts in the handouts panel. You're going to find 4 of those in there for download. If you can't get your computer to download the items, don't worry, because a follow-up email will be sent with a link to the documents. This session is being recorded, and if the technology cooperates, we will post a YouTube link to the video of this session on the OTEC website once the conference completes at the end of next week. Also, you will be receiving a certificate once the conference completes for 1.5 CPDs for complete attendance at this session. If the session runs over, the certificate is not going to be modified to include the additional time, but we do encourage you to stay on if the session runs over. Just please note that no additional CPD credit is going to be given. Thank you for your attention, and I will now turn things over to Jacque.
Thank you, Victoria. Hello, everyone, and welcome. My name is Jacque Annarino. I will be moderating today's session. As you heard Victoria mention, please feel free to submit your questions at any time during this session in the question box. We're going to hold all questions until the end after all the presenters are finished, and we'll address as many as we can in the time allowed. We have a wonderful panel of experts lined up for you today. So we'll just go ahead and get started. As I'm sure you know, early, effective, and continuous public involvement brings diverse viewpoints and values into the decision-making process. Transportation agencies can increase meaningful public involvement in planning and project development by integrating new and diverse methods into their overall public involvement approach. Our first group of presenters will share their ideas for using innovative approaches to engage the public. We will hear from Neil Jurist with the Mid-Ohio Regional Planning Commission, or MORPC. Neil is the director of MORPC's Communications and Engagement Department. In this role, she serves as the agency's chief communications officer and oversees the agency's public information, engagement, diversity and inclusion, membership, and events programming. Neil's career spans more than 15 years of progressive experience in marketing and communications. Neil received her Master's of Business Administration from Ashland University and is also a proud graduate of The Ohio State University with a bachelor's degree in criminal justice. She holds certifications in crisis communication, media training, measurement and analysis, and risk reputation management. We will also hear from Thea Ewing, also with MORPC. Thea leads the transportation planning efforts for both the agency's Metropolitan Planning Organization and the Rural Planning Organization. She is an 18-year public servant focused on transportation, economic development, and community planning. Thea has worked at county, regional, and state levels of government. She has a BA in Public Administration and Urban and Regional Planning from Miami University and a Master of Public Administration from Wright State University. Thea was selected by Columbus Business First as one of the 40 under 40 honorees for being a mover and shaker in the Central Ohio community, most notably for her role in Smart Columbus, the Hyperloop Midwest Connect proposal, and a downtown employee bus CPAS program. She is a member of the American Institute of Certified Planners, the Ohio Association of Commodores, and is the current president for Clean Fuels Ohio. Before we hear from these ladies, however, we will first hear from Laura Whitman with Razor Marketing. Laura offers more than 20 years experience developing and implementing public outreach and engagement programs for transportation, construction, and infrastructure projects. Laura has led community outreach and public involvement initiatives for a broad variety of public agencies, including the Ohio Department of Transportation, the Kentucky Transportation Cabinet, and the Ohio-Kentucky-Indiana Regional Council of Governments, just to name a few. Laura holds a Bachelor of Science degree in Public Affairs and Environmental Management from Indiana University and received her Public Relations accreditation from the Public Relations Society of America in 2002. I would now like to hand it over to Laura.
Hello, I am setting things up at this point, and good morning. I am very pleased to be a part of this, and thank you all for coming. As Jackie mentioned, I'm with Razor Communications in Cincinnati, and am delighted to talk with you about expanding your reach through virtual public engagement. Now, as Jackie mentioned, we talked about why do we do public involvement? It is the right thing to do when you're working in people's community. It's a good thing to involve them in the conversations of things that might impact them and impact the environment around them. It's also required by NEPA. We're all very aware of the NEPA requirements, and that is another reason we go out. But really, public involvement, it's good public involvement fosters understanding. It's good to let people know what you're about to do and why you're about to do it. It builds relationships, it facilitates an exchange of information and ideas, and it really can help the project development process advance more smoothly. I've been working in the communications field for quite some time, and we've all been in the industry working with the community, and we've seen that communications have changed. And one of the biggest instigators of this change is the advent of the smartphone and tablets. And as a result, with all the advances that have been going forward, these are wonderful things, but we're working faster, we're working more. And as a result, people have less time. And we can no longer expect people to come to us, and we have to go to them. And one of the best ways for us to do this these days is virtual public engagement. Virtual public engagement, even though we're getting a lot of conversation about it now, it's not new. We've been doing it for quite some time. In fact, websites is a really great example of this. Websites are the front door to our projects these days. They're the first place that people to go to get information. They tell us the who, what, when, where, and why. We've done this, we know how to do this, and our websites are getting better and better these days and more interactive, and that's a great place to be. But websites themselves are fairly passive. We still are waiting for people to come to us. So one of the things that we do also is to go out with email communications. And this could be as simple as sending an email from your account, or you getting as fancy as the email newsletters that we have up on the screen at the moment. With the email newsletters, you can provide overviews on your projects, you can provide project updates, construction updates, include maps, videos, surveys, but all of these are great ways to get your information out, and you get them into the hands or into the devices of your audiences. Social media is another important tool, whether you love it or hate it, it's here to stay. And Statista.com actually had a statistic that 48% of adults are getting their news from social media. If you break that down a little bit further, Forbes did a study last fall that said that of the people who are getting their news from social media, Facebook is still the leader in where people are getting this information from, followed by YouTube, Twitter, and Instagram. And these numbers of, as I mentioned, these were from last fall, so they've changed a little bit now that we've been through what we've been through over the last 8 months. And actually the numbers have dropped a little bit, but the story is still pretty much the same. People are getting their information and their news from social media, so we need to be out there and make sure that our projects are represented, and represented accurately. Online surveys and comment forms. I'm sure all of you have been in meetings and opportunities, engagement opportunities where you're handed a piece of paper, paper survey or comment form, and we in the past have been very pleased with getting 50, 100 of these comment forms from our public meetings. However, virtual engagement gives us an opportunity to really expand that reach, and by sending these out, pushing them out through email, through social media, through even sending links in media relations, putting them on websites, text, we can get a lot more input in our surveys and comments forms. And the forms themselves, they are interactive, and it's actually, know if you are kind of nerdy like me, but I like pushing the buttons and seeing how many people answered the same question in the same way, or what's the trends. A lot of the programs allow you to see those trends live as you're working through them. We also like to include mapping. If you look at the right hand of the screen, some of the questions that we include are, tell us where the pain points are. Let us know where you think some improvement should be. This map is an example of project area that we highlighted, and the map below it with all the little black dots are the locations where people said, yes, I've had problems at this area. And this tool itself, it not only helps the project team really isolate areas that they need to look at, but it's also a tool that we can use for communications and say, this is what people in your neighborhood, what in your area, in your region are saying where the problems are, and these are the problems that we're trying to address. As I mentioned, we've had great success with these surveys. In fact, last fall, we had a public meeting for a project in Northern Kentucky. Had about 100 people come to that meeting, and we got 700 people answering the surveys in the comment forms. We did another one with the I-275-75 project, also in Northern Kentucky, and we got 2,300 people who looked at the survey, and of those 23 people who actually looked at the survey, we got an 80% response rate. So we got some incredible data for that. And one other thing I wanted to mention as far as the surveys is there's lots of tools to send them out, but one of the more exciting ones these days is geofencing. And this is something that as somebody's driving through an area, there's signals or receptors on their cell phones, and we can track that and then ping them with a survey, say, how was your drive? And get some data from them in that way. So many different opportunities to engage the audiences virtually through surveys and comment forms. But the rest of this, I want to talk a little bit more about public meetings. Virtual public meetings is one of the areas that we really haven't touched much in the past. And at this point, Victoria, if you could launch the poll, I do have a question for everybody and want to get an idea of what the, I believe the poll is coming up.
I've got it launched there.
Okay, I'm sorry.
All right.
My question is, I'm sorry?
I said people are definitely voting.
Okay, great. The question is, have you noticed a decline in public meeting attendance in recent years? And in our experience in public meetings, we definitely have seen a decline in the public meeting, and it's a question that we've received of what do we do? And one of the obvious answers for us has been, well, we need to look at bringing the meetings to people virtually. And but there has been some challenges on that. And before I get into that, though, I would just like to share the results of the poll.
Yep,
and
we've got 29% that chose yes, 19% that chose no, 45% said they weren't sure, and 7% were brutally honest with us and told us they were just here for the CPDs.
Perfect. So, but we have definitely, with some of the answers, we can see that there has been a decrease in attendance at public meetings, and definitely clients and organizations have shown some discussion about, can we do this virtually? But there has been a hesitation, and that really is rooted in the fact that there's a lack of comfort in meeting on virtually, and there's been so many unanswered questions. Would it work? Would people participate? Would they know how to participate? Would it double the workload? How do you collect input? How do you manage the crowd? And added expense. Budgets are so important on all of these projects, and money is set aside for in-person meetings, but the cost of adding a secondary type of meeting through virtual is just not something that people have been quite ready to bite into. However, that changed literally almost overnight. Earlier this year, with the advent of COVID, when COVID shut us down, we all started participating in public meetings. This is professionals, students, friends, churches, families. Everybody was on the public meetings, and our knowledge and our comfort levels just absolutely skyrocketed. Technology capabilities improved daily, and by April, meeting virtually was ingrained in people professionally and personally. And with that, we cleared one of the biggest hurdles to virtual meetings. People's knowledge was there and their comfort level is there. And many people started talking about and doing virtual public meetings. And since then, two types of meetings have emerged. The first one is virtual open houses, and these are a little bit more of a passive meeting, but they're information that's posted up on the internet, but it has a specific purpose. This is a little different from a project website because we have a goal. We want to get people's input on a specific topic, whether it's to evaluate alternatives or to share information about their experience in an area or share ideas. But we have a very defined purpose for this meeting. In a virtual open house, there are no live components. All the materials are already posted online, and people can come visit the information and read through the materials and participate in any surveys 24/7. Comment forms are also integrated. They can share their input up until a certain time frame at the end of the comment period. So people know that you have a window to go through this and to get your information in. And at the close of that period, the information that's provided will be used to help inform decision making for the next steps. Virtual open houses also require notification and formal notification process and documentation, very similar to what you would do in a in-person open house meeting. This is an example of an online open house that was run by D8 earlier this year or last year. And as you can see, it's providing some information about what the project is. It's got the project overview. There's a virtual public meeting page that tells you why they're holding the meeting. And internet access difficulties give you some information about who to contact. There's video presentations, information about the project, and then at the very end, you can click on a survey and provide your information and feedback about the project. Also on this page, there's all the related meeting documents, and there's a timeline. So it's all a very good, solid, concise place for people to get their information. Now, how do these compare with a in-person meeting? Many of the same components. They all have the specific purposes. Materials are provided, comment forms. So they're very similar, except it's done online. Now, the other type of public meeting that has emerged are what we're terming your true virtual public meetings. And this is when you come in and you, again, you have your specific purpose, and you have a presentation. It can be either recorded or live. But the fact that you have a live question and comment session is key for a virtual public meeting. That is one of its big differentiators. Is it's an opportunity for the public to call in or watch online, share their questions and comments via chats, what have you. Materials are posted online. Comment forms are also integrated, and again, you have a defined time frame, and it requires a formal notification and documentation process. And if you compare this to an in-person meeting, once again, you see that this is very similar to the in-person meetings, and the main difference is it is online. We have found that public meetings held in this manner, they're actually succeeding. People are enjoying them, and we're able to expand our reach. Some of the reasons for this is that there's reduced time commitment on the participants' parts. They can jump in with whatever they're doing in their lives. And in fact, I was on a meeting last night where one of the participants mentioned that she was there listening into the meeting and engaged in the conversation, but she was also there watching her son's soccer team. So she didn't have to pick and choose. She was able to do both, and people are responding to that. So they're convenient, and there's multiple ways to participate. You can participate by phone, telephone lines on many of them. You can watch online. You can watch it on your cell phone. You can watch it on your desktop or smart device. So there's many ways you can get the information. And even if you can't participate in the meeting during the set time, one of the biggest conveniences are these can be recorded and posted online so people can watch them later on their own schedule. We could spend hours talking about the different platforms to consider, but since we do have a time limit, I just wanted to highlight some of the features that you should consider when you're looking for an online meeting platform. And the first thing to look at is security. You want to make sure that you maintain control of your meeting. That the information that you are presenting is being out there and not somebody else's. You want to manage your participants and manage their audio and visuals so that you can still present your information and not have interruptions distracting you as you go through your presentations. You also want to have low barriers to participation. And what I mean by this is you want to make it easy for your audiences. Capability of having them just log into a website or go to a URL and participate in the meeting. Probably don't want people to have to download a program in order to participate in the meeting. And registration for a private meeting, having people register ahead of time and getting a password, that's a good idea. But when you're getting into a public meeting, you really don't want to have to require that. And so there's lots of ways to do this in platforms that will help you manage that process. Also want to look at the available feedback channels, not just participating online and in the chat, but can people call in by telephone? Can they leave a voicemail? Can they send in questions via email and chat? And how does that manage? How will your team members manage those elements of the meeting? Is it easy? Is it complicated? Those are all the sort of things that you're going to want to look at. Also, one of the beauties about working and conducting meetings online is you can have transcription services integrated into the program. So these will capture not only your presentation, but the questions and comments that are asked and shared, as well as the responses that are given. And one of my favorite is that you can record it for future viewing. Now, before I close, I just wanted to go through a few of the public meeting best practices and lessons learned that we have experienced over the last 8 months and even further back. But so many of us are working with new technology. So one of our biggest and most foremost tips is practice, practice, practice. And this is all members of the team who are going to be involved in the meeting should be involved in your practice session and practice handing off sections of your presentation to the next person. Practice answering questions that come in from the public, and just make sure you know and are comfortable with what you're doing before you go live. Also, share your presentations with another team member. This comes into play. We've seen and experienced times when the lead presenter who was going to share their presentation suddenly, for some reason, even though they had used the program many times, could not get on. And it just wasn't working. The internet wasn't working. We've heard stories of power outages. So if another team member has your presentation, they could still play it and you can tune in and narrate it by phone. So there's lots of options there. And here's one. Make sure to turn off your notifications prior to the meeting. Other people don't need to see your messages from your family or other colleagues as you're presenting. Queue up your programs ahead of time. Make sure that everything's working and going smoothly so that your presentation can continue smoothly as you're talking. Log into the presentation at least 30 minutes early for a tech check. Make sure their audio and visuals are working smoothly, that the transitions are working so that you can troubleshoot anything before the meeting begins. We highly encourage that you use the platform that you're using, use their chats to talk with each other rather than opening up a secondary program, because this will eliminate confusion between your team and the presenting team. Also, always mind your angles and your background and your lighting. These are some examples of, I'm sure, things that you've seen throughout many presentations. Either you're backlit, you only get the top of your head in the presentation, or you're leaning back, so it's an unflattering and not a great position. So just make sure that you're well lit and you have a clean background and good lighting. Also, we highly recommend using desktop or laptop. This does usually go without saying, but there are times that we have seen people using a cell phone. And cell phones can absolutely be used in emergency, but if you do have to use a cell phone, make sure it's stationary rather than holding it in front of your face and moving, because it does tend to make your viewers a little seasick if you do that. And you also get some very unflattering photos of people's faces when that happens. And finally, our last tip is act as if you're on at all times, even though you may be done with your portion of the presentation and think your camera's turned off. It may be that something happens and your camera is not turned off, so you just want to make sure that you're continuing to behave as you would want conveyed through all portions of the presentation, even if you think you're off screen. With this, I would be delighted to answer questions. We are saving those to the end. So at this point, I am pleased to send this over to Neil and Thea, who are going to talk a little bit more about mapping. And you will learn some more of the virtual public engagement techniques. So thank you very much.
Thank you, Laura. Appreciate it.
Mm-hmm.
Okay.
And just a moment, I am... There you go.
Wonderful. That was a great presentation. Let me get everything set up here. Can you see my screen okay?
We can.
Wonderful.
We just need to put it in the slide view mode.
Okay. Yes, I believe it's there now. Let's see. There you go.
Looks good. Thank you.
Thank you. Well, again, thank you for inviting us here to talk about a few of our favorite topics, social media, interactive mapping, and engagement. I think Laura did a wonderful job of setting the stage for us. And so what we wanted to do is to share a case study, if you will, talk about how we had to pivot at the last minute in light of everything that was happening with COVID. So again, my name is Neil Juris, and we have Thea Walsh, and she will be jumping in a little bit later in the presentation. So to set the stage for you, last year we knew 2020 was going to be a busy year for us, but little did we know how crazy this year would be. And so it was very unusual for us to do a MTP, a Metropolitan Transportation Program, and a TIP, a Transportation Improvement Program, open house in the same year. And so typically we do that, we kind of alternate those years. But we knew first quarter of this year was just going to be crazy. So we had a very good in-person open house in January. We had more than 100 attendees. And so as you can see, we had blown up images so that each area of the map, we could discuss it, each portion of the plan. And so typically when we do our open house, we have representatives from the Transportation Infrastructure Development, that's a mouthful, department come in, they answer questions. People are able to provide comments. We give them an option to provide comments online or do it in person. And so everything, I would say, it was by far a successful event. So then again, we start planning in January, actually the previous year, and then in February, we actually have the open house. And so we were looking forward to another successful open house. Well, March happens. And so we were scheduled to take we were scheduled to have it on March 31st. And so around maybe mid-March, I would say around the 13th or so, we started getting indications that we were not going to be having an in-person open house. We never did a virtual one, so we were trying to figure out what we were going to do. And so it just so happens on March 13th, we decided to do kind of a soft close to our office to test out our technologies. And guess what? We never returned to the office. I'm sure that scenario is a little bit familiar to many people. And so during the course of that time, we were still planning, trying to really decide, okay, how can we take an in-person event and make it virtual? At the time, we were using Microsoft Teams. And so we just said, okay, let's just continue on with our promotions. We're not going to be able to delay it. It's a requirement. And so we're going to continue to have it. So we met internally to decide, okay, how can we replicate an in-person event? And so typically, as you saw in the first photo, we do these large display boards. And so we decided to use our website as a great resource. And so we ended up blowing up those boards and putting them on our website. So at this point, I'm going to turn things over to Thea, because this is where we start getting creative and going into our interactive mapping.
Good morning, OTEC, and thank you, Neil. Yeah, so when Neil came up with this idea of doing the boards on the website, I was like, oh, okay, yeah, just maps on the website. But it was very interactive. It followed the flow of the actual room that we typically put together for an open house. And it was a very helpful tool. She developed with our web vendor an actual click-through room, if you will, of all of the displays we would normally have in an open house room, so that it wasn't like you had to go to our website and sift through all of our information, in addition to the interactive mapping tools that we typically have. Neil, if you'd like to advance. All right, so on our website for the Metropolitan Transportation Plan and the TIP process, we typically do have an interactive mapping process for the citizens of our region. This is just like a little window to what that looks like and how to access that web map on our website. We did this for our last Metropolitan Transportation Plan 4 years ago. It was very helpful then, and it was equally as helpful this go round. So a little bit about it. We have received over 1,000 comments via this tool every time we've done it. Citizens can give it a like, a dislike, or a neutral. They can make comments on a project. They can draw a project on the map. It has to be approved by our staff before it actually goes up live. So that's another beautiful feature of this. Our team develops this via the Esri app tools that you can get via the ArcGIS software. We also have done story maps this way as well, but this is a great public engagement tool, and we found that we get much more comments now that this is out there virtually, even before we do public involvement meetings, and then we use that information to gauge how we're going to set up those public involvement meetings. All right, I'm ready to move on.
All right, so I'll jump back in. And so more or less, we had to start again thinking about, okay, what is the best way we're going to execute this? And so initially, and Thea, she can chime in on this, we're like, we're going to do Facebook Live. So we started out maybe 3 weeks before the event, because you heard Laura talk about the importance of practicing. We cannot even overstate that. So we started practicing, and we quickly found out that we were missing something. We were not able to go live on our YouTube or Facebook. And so we had to pivot back to Microsoft Teams, and it's an excellent resource, but I think we really wanted to be more inclusive by being able to share it on our YouTube and Facebook pages. So we had to, again, pivot again and figure out like what was the best strategy. So we started thinking about a good tactical plan for social media. So as you can see in this particular slide, you have Thea, we have pictures of Thea, and so we started doing promo videos. We wanted to build excitement. And so the morning of actually, we did a promo video with Thea. And so we were trying to get our numbers up, trying to direct people like how they could sign in. And so what we ended up doing is embedding the link on our website. And so people could join in that way. And so we would share the link from our website to all of our social media platforms. Okay, Thea, back to you.
Also, part of that practice, I will throw in that in addition to us practicing and doing this live, I pre-recorded this with my presentation in the event that something went wrong and we needed to use the recording. So we were prepped multiple directions ready for if we had to get this done. So the event execution, I felt like really went well. We had over 200 people log in to this. A general meeting for us is at around 100 people anyway. We already have to man a room up with a lot of staff people to answer all the questions. Our format is typically open house with a presentation towards the end, but leaving time for questions. And there's probably about another like half hour at the end where we tend to take time for answering questions. So this wasn't much different. We had the gallery that Niall had put together for people to look through. We posted that we were going live at a certain time. We went live. We had people posting questions throughout that time. And then we answered those questions at the end. I will say too, it took more than just me to be able to answer all the questions. We had a team waiting in the background who were also kind of in the okayed presenter group when we went live. They were taking those and answering live while I was talking. And I would read their answers off of the responses too, and then kind of add my own take on it, just in case there was additional information I wanted to put out there. So this is not something, it's not like just you and your Niall. This is, your Niall, my Nick, so it all, like, I think there was about 5 more people behind me making this happen. This is a team effort. This is not like a solo venture. Then we also had it recorded and Niall was able to post it afterwards. We were able to take comments throughout the comment period on our presentation, and you left those boards up for a while, Niall, for people to look through. So all in all, I think the actual media that was presented for this lasted much longer than an in-person meeting and had the reach much further than a typical in-person meeting.
Mm-hmm. I think so. And I think in thinking about it, we learned a lot of lessons, like many of you. Virtual is something we'd never done before. We talked about it, but it was something that we had never done. So some of the lessons learned, I'll take part of it, and I know Thea will finish up the rest. We learned that it was important to have another view because during the presentation, there was a 20-second delay. And so we learned to have natural pauses. We also learned, we were saying that we tried to do YouTube, Facebook, Periscope. We learned that in order to share our Teams feature, we needed encoding software to make the most of it and to really be truly inclusive and make sure that we're hitting different platforms. Like Thea said, always have a plan B because we pre-recorded it. We wanted to make sure just in case there was an outage that we would still be able to continue on and maintain that continuity. And so again, you've heard Laura say this, and we've said it a couple times, practice, practice, practice. Practice to perfection. And remember to give yourself grace because I think people are very much understanding. I mean, we've all been on webinars where kids have come in, which I think is hilarious, by the way. There's been pets. And so just give each other grace. You're not going to have that same in-person experience. And it's very important to not try to necessarily recreate it. So for example, if you're going to do an all-day workshop, it's not realistic to say that you're going to have somebody there really for 8 hours. And so what we had to do, we had to learn to kind of think creatively, think about natural breaks, and just think about what works best for our audience. Anything else to add, Thea?
Yeah, on the plan B, I think that was very important. And in addition to that, the plan, I feel like it goes along with plan B, is all of your teammates that are going to be helping on this should be able to help guide citizens through connecting, because we were using Teams that first time and it was the only tool we had. And even with YouTube, we did that with the summit a couple weeks ago. There were people asking questions like, I don't see the comments. How do you log into this? Where can I view the maps? You need to have somebody available and a quick response on that. So I think all of us were handling those how to access questions. You got to continually stay on top of that. The other thing is the video, the live video, whenever people get into that, if it's just silent, you need to have a slide up that says, you've reached the meeting and it's going to start at this time, not just the opening slide, because I think they get there and they're like, well, there was nothing going on, and so they log out. Another thing we did, we played music during that time, and occasionally we'd come on and say, all right, the meeting's going to start in about 5 minutes, take a look at our web maps, so I think it let people know they have reached a live event that's getting ready to happen. And that was another just thing that I felt like made it a little better than what it could have been with just being silent at first. So thanks, everybody. We're so excited to share our story, and we're just learning, and we hope you continue learning on how to reach out to the public about your projects too.
Thank you so much.
Thank you, ladies. That is some really good information that you're sharing with everyone. Very useful, very helpful. Thank you so much. Our next topic is Seeing is Believing. Using ODOT's drone footage to gain the public's trust. Even though roundabouts are a Federal Highway Administration proven safety countermeasure, significantly decreasing serious and fatal crashes, the general public vehemently opposes their construction. When a transportation agency proposes to build one of the public focuses on the same concerns. When ODOT District 8 conducted a recent public involvement meeting for a proposed roundabout project, the authors set out to film a roundabout. Video, drone footage, and 3D models were utilized in the public involvement meeting with great success. Future controversial projects can better prepare for public involvement meetings that result in more constructive discussions and engagement. Our speakers for this portion of the session are Daniel Kammer and Keith Smith with ODOT District 8. Daniel has been working for the Ohio Unmanned Aircraft System, or UAS Center, since March 2019 as a contract employee and transitioned to full-time in September 2019. Since joining the team, he has logged roughly 340 hours of time flying or directly supporting a flight operation and established a maintenance program for the department. Prior to joining the UAS Center, Daniel worked as an aircraft mechanic in general aviation at Whitewater Aviation and as a test technician contractor with GE Aviation. Daniel is an aircraft mechanic with an airframe and power plant license, a Federal Aviation Administration Part 107 UAS license, an associate degree in aviation maintenance technology from Cincinnati State Technical and Community College, and a bachelor's degree in aviation maintenance and safety from Embry-Riddle Aeronautical University. Keith Smith is an environmental engineer and the district environmental coordinator for the Ohio Department of Transportation in District 8. He has been with the department for 29 years, working in environmental engineering, NEPA compliance, and project management. Keith is a licensed professional engineer with a bachelor's degree in civil engineering from the University of Cincinnati. I would like to now hand it over to Daniel and Keith. Gentlemen.
Thank you, Jackie. Okay, is everybody able to see my screen then?
Yes, we can see it. It looks great.
Okay, great, thank you. Well, all truth passes through 3 stages. First, it's ridiculed. Second, opposed. Third, it's finally accepted as being self-evident. This is a quote from the German philosopher Arthur Schopenhauer, which we think best represents the truth about how safe roundabouts are and the public's reaction to them. Good morning, I'm Keith Smith from ODOT District 8. Today we'll discuss how District 8 used drones and 3D technology to engage the public stuck in stage 1 and stage 2 of the truth about roundabouts. In the winter of 2020, ODOT was going to propose a single lane roundabout at the intersection of 2 high-speed state routes in rural Clinton County. The nearest roundabout is over 10 miles away, so we knew this was going to be a hard sale. We would need to capitalize on some of our previous efforts that had shown some success in the past to keep the public meeting focused on constructive criticism of the project and not instant rejection just because it's a roundabout. The previous year, the district had used MyoVision, basically a camera on a pole, to film a proposed roundabout location in Claremont County. an existing roundabout that had roughly the same amount of traffic as the proposed location in Clinton County. The footage was used in the public involvement meeting with some success. We learned that the video was an effective tool to help communicate how roundabouts work to those who didn't like them. The experience taught us how important it was to make sure we got the setting correct of what's being filmed and make it as close as possible to what was being proposed, since the public used that information to either validate or invalidate the video that was being shown. By invalidating the examples shown, the public was able to maintain their belief that a roundabout won't work, or that ODOT engineers just like roundabouts and like to mess with the traveling public. Moving forward, we focused on the setting of our next roundabout to be filmed for the Clinton County project. We needed an apples to apples comparison. Up to this point, we had sort of compared apples to oranges, and we needed to be much closer, like a Fuji to a Red Delicious apple comparison. The setting of the comparative roundabout needed to be in a rural setting with 2 high-speed approaches, a trucking route, and the same size roundabout diameter. We also needed to improve the perspective of the roundabout being filmed. The Maya Vision didn't provide a good field of view of what was going on when approaching a roundabout. Using a roundabout database called roundabout.kilson.com, we found 2 roundabouts that we thought represented what we were looking at. One roundabout in Clark County fit our setting criteria of a rural setting with a high-speed approaches, a trucking route, and the same size roundabout as was what was being proposed. We also found another roundabout that fit the requirement of a trucking route and diameter, but it was in an urban setting with low-speed approaches in Franklin County. This urban setting was to be used to prove to the public how a roundabout has the capability to handle higher volumes of traffic. But this video ultimately wasn't used in our presentation during the PI meeting. So to improve the field of view, we needed to be able to film the roundabout from further away to capture vehicles approaching the roundabout. Drones are an obvious solution to that problem, so we tasked our district UAS pilot, Daniel Kammer, to film these intersections. Filming an intersection with a drone has its own restrictions and problems to solve. Daniel can further explain those next.
Hey, thanks, Keith. Good morning, everybody. I'm Daniel Kammer, and I'm a regional pilot for the Ohio UAS Center. I fly operations throughout the state utilizing the Part 107 UAS license. I was going to go ahead and describe some of the limitations and difficulties that we've associated with the traffic monitoring and observation operations, as well as some of the equipment we've used and some of the lessons learned. So first, altitude limitations. Part 107 flights are limited to 400 feet above the ground, in part because manned aircraft are generally supposed to be at least 500 feet above the ground, and this, in theory, will prevent airspace conflict. This restriction sometimes limits our ability to actually capture the full intersection in a single shot. A notable exception is that you can fly an unmanned aircraft more than 400 feet above the ground if you're within 400 feet of a structure, such as a cell phone or water tower. The aircraft is then limited to no more than 400 feet above the top of the tower. You have to be, of course, within 400 feet of the tower. And so if the tower, let's see here. In this case, you need to be using extra caution because at this point, you're now approaching manned aircraft altitude. For an example, the Clark County intersection that Keith was talking about is at State Route 41 and State Route 235. This intersection is 2 55-mile-an-hour routes, and the intersection itself has a large footprint. But in my case, what helped me out is that there's a cell tower really close to the intersection, probably just a couple hundred feet to the south. The tower is about 300 feet tall, which allowed me to fly the aircraft to nearly 700 feet. And in turn, I was able to get the entire intersection in a single camera frame, and I didn't have to use a second camera. During this flight, I was monitoring an aircraft or aviation radio, communications radio, as well as listening and visually scanning for other aircraft, because at 700 feet, there was a chance of, there's a chance of conflict. But the altitude itself allowed us to capture the roundabout and its approaches as the traffic was decelerating from 50 and then navigate 50 plus miles per hour and then navigating the intersection. In this case, we were able to capture the whole intersection from almost directly overhead, and it provided quite the unique perspective of vehicles entering, navigating, and then eventually exiting. We captured vehicles of all sizes up to and including tractor trailer sized. Other factors that limit the use of our UAS is essentially not flying over people. And for our purposes, this also includes moving vehicles. So we cannot cross continuous traffic. The example of the New Albany roundabout that's at US 62 and Market Street. And the urban setting presented a set of challenges that how are we going to actually get to the roundabout, and how are we going to find a proper place to fly from if, in such a setting. During the planning, I identified a church that was nearby, and they had a large lot, typically unused during the week. And so I contacted their administration and let them know who it was, what we were going to do, and they agreed to let me come out and launch and recover the aircraft from that lot. And they also let me know that they owned some property that I could, fly over. And so after the first couple minutes of flight, I was able to identify a place using their property where we could fly the aircraft and get a good view and collect some good data on that roundabout as well. So one other limitation or regulation, be remiss if I didn't mention it, while planning a flight, whether you're in an urban or a rural environment, you have to know where the nearby airports and helipads are and what traffic you can expect to come from them. The closer you are to an airport, obviously, the more chance you have of having a conflict with a manned aircraft. For more information on how to do the Part 107 license, I think there's going to be a link to the LTAP class that the UAS Center has helped put together. And that will be presented, I believe, in the handouts in this presentation. Keith, next slide, please. So now I'm just going to move on to the equipment we actually used. And typically for traffic monitoring, especially when you're hovering for a longer period of time, our go-to aircraft is the DJI Matrice 210. There's actually one over my shoulder here as well. This model combines good battery life, somewhere between 20 and 30 minutes, with an incredible stability system and a wide variety of aircraft sensors and cameras. The price point of the M210 can actually make it a little bit cost prohibitive if you don't have other missions that you're trying to fulfill. The kit the operating kit that we used cost nearly $40,000. So I feel like it's important to point out that there are other aircraft that are capable of doing this same mission using a single camera, single aircraft. And some of those examples are the DJI Mavic 2, the Phantom 4, and the Inspire series, as well as a Skydio 2 or something along the lines of a Parrot Anafi. These aircraft can be acquired for typically less than $3,000, and they all have good stability and a good camera, but they lack the general usability and sensor interchangeability of the Matrice 210. Keith, next slide, please. So I was going to go ahead and wrap up my little talk about drones with some lessons that we learned. First, we knew that the weather is going to affect, flights, but we found out that it affects more than just our ability to put an aircraft in the air. For example, with snow on the ground around dark pavement, which I think will be illustrated in the video coming up, you can't actually see some of the vehicles as they move through the intersection, and so therefore we didn't get as much useful footage as we had hoped. Local weather also affects speeds and traffic volumes at the different objective sites. So while it might be a great day for flying, it might be a bad day for data recording. And second, time of day is crucial. It's hard to get a good idea of how good or bad a traffic flow is if you don't catch it around a peak time. Some things to consider are nearby school arrival and dismissal times, as well as restaurants around lunch hour, and of course the beginning and the end of a workday. Typically, we're trying to record intersections when the traffic volume is highest, and pinpointing these times helps us be more effective with our mission planning and execution. I have to admit, I've been late to a flight location or two because, well, I've mistimed the traffic peak and ended up stuck in the traffic I was trying to record. But if all goes according to plan and the weather cooperates and the traffic footage looks useful, I'll then take it and I'll upload it to one of the ODOT drives, and I will send it to those working on the project for them to use or not. And with that, I will hand things back over to Keith, and thank you.
Thank you, Daniel. Now that the district had done the drone footage, the next task at hand was a 3D video of the planned roundabout. Since the roundabout was being designed using Bentley's Open Roads CAD software, ODOT was able to use AutoTurn Pro and LumenRT to create 3D renderings of the roundabout for the first time. At this time, or as this was the first time, there was a little bit of a learning curve where our design team was able to produce 2 different 3D renderings. One was showing the traffic flowing through the proposed roundabout, and the other showing a semi-truck making a left turn. Now you may think the next part of the story is presenting the videos to presenting the videos to the public and describing the reaction, but there's another critical step. You have to edit the videos being captured to this point into a pleasing video experience to the public view. Next, we'll play a video where Anthony Pankla, who did the video editing, will show the problems we had with the raw video footage and how he used the video editing software to resolve these and enhance the overall presentation.
Keith, the start button is in the bottom left-hand corner of the screen. You'll need to hover there to push start.
Are you seeing the video now?
We are.
Video is a popular exhibit with many people watching more than once. We still receive the same common concerns, but people having the video to reference made it much easier for the public to accept that the roundabout being proposed isn't unique. The public was able to see a very similar community had built one, and it did improve safety while accommodating large vehicles in a rural setting with high-speed approaches. But not everyone was satisfied that this was an apples-to-apples comparison. One person refused to accept the video as evidence that this roundabout would work because the roundabout being shown had no businesses on the corners and it wasn't near an interstate off-ramp. The majority of the public did see it as a valid comparison though. The video was located near the other exhibits and the rest of the staff was able to refer the public to watch when they had hesitations about the roundabout being safe on a high-speed route or that it can accommodate the truck traffic. We let the public see with their own eyes that a roundabout can work. Overall pushback about how the roundabout wouldn't work due to large vehicles, high-speed approaches, and in a rural community were reduced. The public instead focused on other issues and concerns that were constructive, like how will the roundabout handle event traffic of the Renaissance Fair that is actually nearby there. With the drone video presentation being so successful for the roundabout, we think it'd be a great tool for other controversial projects like R-cuts, DDIs, and road diets. Applying the same concepts and principles of mimicking the settings as best as possible and letting the public see an existing project can be a better show that the proposed project can work in their community too. A key aspect of the project that we want to capture is before and after footage. The more we can show an answer to a question or disprove an incorrect assumption, the more likely we can bring the public on board as advocates and possibly project champions. Numbers and lines on a sheet of paper don't hold as much value to the public as seeing it with their own eyes. Showing an intersection before a project happens and then after can allow the public to see the improvements for themselves. We'd also like to expand our video collection to cover more situations like pedestrian crossings at roundabouts, emergency vehicles using roundabouts, and oversized loads traveling through a roundabout. We'd also like to expand our settings to include various traffic volumes that's a common concern from the public when the roundabouts are proposed in urban or suburban settings. So with that, I understand we're going to hold off our questions, but thank you for attending this presentation, and we'll address any questions then at the end.
Thank you very much, gentlemen. That was really cool stuff, and I definitely see how that can be beneficial with public involvement meetings because seeing really is believing. Okay, our final topic today is practical virtual reality, developing a custom virtual reality driving simulator for public engagement. Seeking to develop new and useful applications for virtual reality in conjunction with public education and engagement, TranSystems has designed and created an interactive driving simulator, using commercially available hardware and software. The simulator uses a virtual reality head-mounted display and realistic controls to create the illusion of driving a vehicle through the proposed infrastructure designs, allowing DOTs and stakeholders to experience and interact with roadways, interchanges, and bridges, reviewing a design's operation and aesthetics from the driver's seat. This presentation will cover the tools, processes, and lessons learned in bringing this technology to life. The speaker for this topic is Andrew Valente with TranSystems. Andy is an assistant vice president at TranSystems with 25 years of experience in 3D modeling, rendering, and animation for architecture and engineering applications. His areas of expertise include conceptual and full design computer modeling for architectural and infrastructure development, image and photo manipulation, full audio video project development, and virtual reality. Andy holds a bachelor's degree in architecture from the University of Tennessee, Knoxville. Andy, take it away.
Well, hi, everyone, and welcome to this presentation on developing a virtual reality driving simulator for public engagement. As stated, my name is Andrew Valente, and I'm a senior visualization architect with TranSystems. I've been with TranSystems for 15 years and have over 25 years experience in AEC design and visualization, including 5 years working with real-time graphics and VR. Here's a quick list of the topics we're going to cover. A copy of these slides is available as a handout. We're going to keep things relatively high level. This is not going to be a technical tutorial on how to build a simulator, but rather a primer on the basic principles, technology components, and on-site setup and operation, so you can evaluate the feasibility for your projects. And for those people who are not design viz specialists, to be able to communicate effectively with others on the subject and know a little bit about what goes into making it happen. Now, VR is not new, and by now, most people have at least heard of it. The first practical introduction was actually in 1968, but because the state of computing at the time, the graphics were very crude and all the hardware was in the early stages of being invented. To run it, you needed a supercomputer of the time. Now, skipping ahead a few decades, VR technology is now plug and play like any other computer component, and a high-end setup can be purchased for a few $1,000s. So what is it? In a nutshell, it's a computer-displayed simulation based on 3D modeling. It's immersive and viewed from a first-person perspective. You feel like you're inside the 3D model. And it's also interactive and user-controlled. Most uses of VR today revolve around gaming and entertainment, but over the last 5 years, we've seen a migration of this technology into AEC industries for several purposes. Some of the most common include design evaluation and review, remote collaboration, where people in different physical locations can be inside a shared VR experience connected through the internet, job site familiarization, and as training scenarios, which can cover safety on the job site or how to operate different pieces of equipment. A less explored use of VR in the AEC world is as an immersive driving simulator. This is a specialized application of VR that can be used to familiarize local drivers with proposed infrastructure designs, especially unconventional interchange and intersection types, and obtain feedback on aesthetics, sightlines, signing and marking, and driver-pedestrian safety. Since this technology was featured in the TranSystems booth at last year's conference, some of you may have already experienced it. This system was intended for use in the Central Florida roadway project this summer, but was postponed due to the pandemic to spring of 2021. The test project used in the original demo was a diverging diamond interchange that was designed by TranSystems in the Melbourne, Florida area. And feedback from the engineers who worked on the project and have driven the completed interchange is that the VR experience felt remarkably similar to the real thing. The basic concepts I'm going to cover related to VR are the special hardware needed to view the immersive experience, some of the typical software used to create the graphics, the special hardware that is unique to a VR driving simulator, and the type of computer needed to drive this technology. A lot of what you will hear is common to all VR projects, but there will be portions that are specific to a driving simulator. The specialized hardware used for common VR experiences consists first of a head-mounted display, which is referred to as an HMD. This is the headset worn over the eyes, which blocks the user's view of the real world and replaces it with the graphics shown on two small screens inside the device. This is what defines the experience and creates the illusion of being in another place, in this case, an engineering design project. Adding to this, hand controllers are normally used for interactions and movement within the experience. One point I want to cover before moving on is the two major styles of HMD, because it will be relevant to the designing and planning of the driving simulator. The graphics processing for VR can either be done on the HMD itself, in what is known as a standalone unit, or on a laptop or desktop computer to which the HMD is connected, usually with a cable. Standalone units offer a more simplified setup and lower cost of operation at the expense of less processing power and limited user interface options. The driving simulator we'll be covering today requires a computer-driven HMD for both the processing power and non-standard user interface controls. When it comes to the software side of things, we're taking real-world engineering data and applying modern video game principles and technology to create an end product that is educational, entertaining, and engaging to a broad spectrum of people. The software component that makes VR a unique media is the real-time graphics engine, also referred to as a game engine, because the gaming world is where it comes from and where it sees its biggest use. As the name implies, this type of software allows 3D models that have been created to be rendered and interacted with in real time. Geometry created in your modeling program of choice is imported into the game engine, which is used to finish off the VR experience. The type of software can be found as plugins that work directly with an architecture or engineering program for super fast rendering, or turnkey apps that specialize in getting a 3D model into VR easily with a preset toolbox of interactions, or they can be broad-based standalone commercial software just as big as any CAD or modeling program. All of these are good options for different graphics use cases, especially when it comes to interactive graphics. But for something like a driving simulator, where we're going to need to focus on the attention on broad-based commercial game engines. The two most commonly used, especially for AEC, are Unity and Unreal. Over the last couple of years, both have shown a commitment to customizing some aspects of their software to the construction and manufacturing industries, giving us graphics professionals in AEC a wide spectrum of tools for our work. The flexibility these programs provide is also necessary to be able to implement the special input devices and vehicle driving behaviors we need for a driving simulator. One of the benefits of using a mainstream game engine in the development of a VR sim is the ability to add a wide array of specialized digital assets as needed for a project, the most important of which for today's topic is driving physics. This is the programming and setup that controls all of the behaviors of the simulated vehicle our users will be driving. From the things that are readily apparent, like steering, acceleration, and braking, to more subtle aspects like traction, gearing, sounds, and instrument displays. While you could write your own custom C# or Java code for this, it would be extremely complicated and time-consuming. Fortunately for people like me who are not programmers, there are plugins for game engines available for minimal investment. These can be found by searching the integrated storefront in your game engine of choice, and as an added bonus, they typically include sample configurations and presets to get you up and running more smoothly. And if you do have some programming knowledge, these assets ship with all the source code files so they can be customized easily if needed. Just remember to make a backup of the originals before tinkering. There are some useful assets that can be added to enhance the simulation and introduce more realism, but they should be well thought out and used sparingly for VR. One potential option is to have people walking around or additional vehicles driving on the road. These could be preset animations and movements, or something more sophisticated that uses basic AI to be more random and interactable. Also consider adding some trees and other vegetation to soften up the look and feel of the graphics. And a realistic sky, or even weather effects like fog and rain if needed. As with the special physics package, these can all be found in the software asset stores at reasonable prices or sometimes even free. But any of these should only be used if computing power allows, because they can add a lot of complexity to the project, slowing down the display. This is a recurring theme when designing a VR experience. Display speed is king. Now, coming back to the hardware side of things, as mentioned earlier, for a driving sim, this needs to be a computer-based VR system and not a standalone HMD unit. If we're going to be driving a car in the simulator, we need a realistic way to control and operate it. And to do that, we need to return to the world of video games. Originally made for racing games, we find the solution in commercially available steering wheel and pedal set controllers. Typically, these are sold as a set and can be easily found on the internet. The physical setup is fairly straightforward, connecting to the computer through a USB cable. Setting up the functionality requires a little more effort and is done inside of the real-time game software that's used to design the VR experience. Once set up, this device will allow the user to control the car inside the simulation in a very natural way, using the steering wheel to steer and the foot pedals to accelerate and brake. As a matter of practical operation on site, I highly recommend also picking up a wheel stand to go along with this controller. This is a portable, sturdy metal frame to which the steering wheel and pedals can be mounted securely with screws. The alternative is to use the built-in plastic clamps or suction cups on the steering wheel assembly and attach it to a table. But I can tell you from experience that method will not last long. It's quite common for a user to become overambitious in a turn or overreact within the simulation and wind up pulling the wheel assembly right off the table, which can be a little distressing from inside the sim and require physically reattaching the unit, assuming it didn't break. The last piece of hardware needed is a lot less advanced, but you will need a chair, preferably one that does not have wheels. Usually this can be provided by the venue, but ask ahead, so if you need to, you can bring one. When it comes to the hardware for the computer for the VR, these points are common to all use cases. Make sure to run it on a high-performance laptop or desktop system. What can make it a bit more of a challenge is the need for it to be portable. AEC project models tend to be big and complex, and best suited to be run on a high-performance PC. More specifically, you're going to want to have a system with a very fast CPU and GPU, because VR really puts the computer through the ringer. If you try to use a lower-end system that is not designed for it, you run the risk of introducing lag into the display and potentially causing motion sickness. Avoiding this is the #1 rule in VR. Now we come to the implementation of the system and on-site use. And here I will cover some lessons learned from having designed and operated VR systems many times. Ideally, any VR setup should be done with plenty of open floor space for both the user and the equipment. While it can be done in a confined space, realistically, there should be at least a 10 by 10 foot area. More is always better than less. When the user is wearing the head-mounted display, they can't see anything in the real world. To bump into something or to be touched by someone they can't see can be a jarring experience. With that in mind, the VR user area should be visibly marked off to keep people from walking by or watching the show at a safe distance. I always travel with a big roll of tape in case there's nothing physical to use like chairs. You want to have a means to safely and securely get the electronics and supporting hardware to the site. The hardware used for VR has a lot of small pieces and wires, so a specialized travel bag is a good investment. These are usually padded and have internal spacers or compartments for all the little bits and pieces. If you have an HMD that uses external movement trackers, usually 2 of them, you'll need tripod light stands for temporary mounting. Be sure to set them up in locations where they will not be bumped or knocked over. When it comes to the computer, I prefer to use a powerful workstation-grade laptop, and I've flown with it in the rest of my setup many times. The items I do not fly with, however, are the steering wheel and pedals and the wheel stand frame. These are too heavy and bulky to deal with on a plane and are sent to flyaway destinations separately. When transporting all of these electronics, whether by car or plane or delivery service, there's always a risk of something being damaged, lost, or forgotten. This falls into the category of lessons learned the hard way. If you're going to be using them, try to bring a backup tripod for the tracking sensors. I have had one break during a flight in checked baggage. Fortunately, it was on the way home from an event. Bring extra monitor cables of different types, and bring an extra power brick for the laptop. Don't forget your big roll of masking tape. And pack an extension cord and power strips. You don't know if you'll have easy access to power where you need it. Hygiene also needs to be considered when we have a situation where many people will be using this equipment one after the next. A head-mounted display fits very snugly on the face, coming into contact with the user's perspiration, oils, or anything applied to the skin. To keep this a pleasant experience for everyone, there are generally 2 ways to approach this. If the HMD has a porous foam rubber face pad, use disposable mask barriers that can be applied to the HMD with Velcro and swap for each other after each user. They come in bulk packs and are pretty inexpensive. If your HMD has a non-porous face pad, wipe it down with a disposable sanitary wipe between users to keep things fresh. The next 2 points go sort of together and help drum up excitement and participation for the VR station. If at all possible, include a large secondary display monitor that is set up to display what the user is seeing inside the HMD. Ideally, this will be a large TV mounted on a tall display stand so that it can be seen from a distance. This serves a few practical purposes. It will grab the attention of people in the room. It will allow people who are waiting for their turn to understand what they'll be doing inside the simulation. And the people who do not want to participate themselves can also get some benefit from the experience. Sound can have a similar effect. Most vehicle physics assets include engine and tire sounds, so turn up the volume on the system a little. On-site operation. First, it is best to have someone knowledgeable with the hardware and software operating the simulator. This is a complicated system and may require some troubleshooting during setup and operation. Allow plenty of time for setup before the event. Explain the controls and what to expect to each person before they start. For most people, this is probably their first time using VR, and just looking around inside the HMD can be a little overwhelming. Give them some time to get oriented before beginning to drive. Give verbal guidance to the user during the simulation. Pay attention to what they're doing. Make sure they don't get into a panic situation. This is easy to fall into, especially the first time. Let them know it's okay to crash. We have insurance. Inject a little humor if they seem stressed. This should be a fun experience. When things slow down, jump in and demonstrate the simulator yourself. Show the people how it works and explain what you're doing to anyone who walks up. And be prepared for people who just don't want to do it. Everyone has their reasons, and even if they won't say it, they're all valid. I usually just let them know that they are in control, and if anytime they want out, just take off the headset. The last thing you want to do is force an unpleasant experience on someone. The benefits of including a VR simulator in your event. Drawings and renderings and animations also have an important place to play in a public engagement event. But a VR simulation is the most realistic way for people to get a feel for the project that is still in a planning or design phase. It is something that really needs to be experienced to be understood. So if you haven't tried it yet, I encourage you to do so. It allows you to get immediate feedback and impressions on driving related issues. Because the software is used to make VR is designed for interaction, different options and scenarios can be built in and changed on the fly. You can test different scenarios for sightlines and obstructions, or try different positions for sign placement. And as an added bonus, it adds some fun and interaction opportunities to the event. Finishing off now with a few issues to watch out for. An inherent risk, especially for first-time users of VR, is a specific type of motion sickness called simulation sickness. Some people are more susceptible to this than others, and it can turn things real ugly real fast. I find it best to bring it up quickly as part of the pre-simulation instructions. If at any time you start to feel sick or uneasy, just take the headset off immediately. You don't have to wait for me. You are in control. I've never had anyone get sick and mess up all my nice stuff, but I have had a few headsets get popped off immediately with a definitive nope. Some people just won't be able to get past it, and that's fine. All of that is common to any use of VR. But when we add driving activity, we introduce a new motion-related factor that is a little more subtle and might be difficult for you to put your finger on first. If you think about it, when you're driving your car in daily life and make a turn or accelerate or brake, you feel the forces of inertia. These can be small or big forces depending on the situation or how you drive, not judging. But even if you don't notice them all the time, you are accustomed to feeling them associated with the activity of driving. Well, these forces are not going to be present in our simulator, and it can sometimes be something that some people will notice. It's usually not a big issue, and many times it won't even come up. The best way to deal with it, other than buying a super expensive motion control platform, is to keep this driving speed down in the setup of the vehicle physics. Equipment stability and durability. Go ahead and use that metal frame base for the steering wheel and pedals. The built-in plastic table clamps or suction cups that come with the wheels are useless. It will just result in someone pulling it off the table and waving it around the air in a panic. I have had it happen. VR can be a visceral experience and a very believable tool. And it feels really weird to be driving toward what feels like a dangerous situation, like a wall or oncoming vehicle, and have the car you're driving come apart in your hands. Bolt it to an immovable object and reduce the risk of having a broken simulator in the middle of an event. And lastly, eyeglasses. something you do not want to figure out the hard way. Most likely they are not needed in VR because the screens are about an inch from the eyes. Inside of the HMD tends to be very tight and has a snug fit by design. And while they may be able to accommodate some glasses, there is still a very high risk of breaking. Yes, I have had it happen to me. Strongly suggest that the user try first without glasses, and if they really need to, tell them to be very careful. And now, for anyone who has hung on this long, the question you want answered: how much does all this cost? The good news is many of these items can be multitasked to many different projects and business development opportunities, and some of them you may already even own. A computer that can handle VR well can generally be found for as low as about $2,000, but consider that a starting point. More realistically, you'll be looking at machines in the $3,000 to $4,000 range. Remember, fast CPU and fastest GPU, and you're probably going to need to transport it. The VR systems will also require a little research to decide what will work best. Suitable systems start around $400, and some can easily reach over $1,000. The steering wheel and pedals can be found in the $200 to $300 range for a good unit, and the wheel stand should cost about $100. A secondary monitor should just be a few $100s, nothing special here, just a big TV. Just make sure it has suitable connections for the computer. The real-time game software ranges from free to about $150 a month. The two main options widely used for AEC fields are Unity and Unreal, and both are very similar in capability. It's just a matter of preference. And the last component is a complete variable, and that's the time it takes to come up to speed on all this, create the digital content, configure the hardware, and test and work out the bugs. It can be significant depending on the level of experience you're starting from, but it can be well worth the effort. And that concludes my presentation for today. Thanks for joining me.
Thank you so much, Andy. That is really cool stuff. I can't wait to try it out. I wish we were in person this year so I could try it out myself. Unfortunately, I think we've run a little long today. Our time has come to an end, but we have everyone's email address and the questions that were submitted. So we will follow up in writing in an email with the response to those questions. We unfortunately just have to leave it there and out of respect for everyone's time. I would like to thank our presenters for sharing their experiences and expertise with us today. The information provided was incredibly useful. Thank you everyone for attending today's OTEC session. If you have additional questions about today's session, please email me, Jacque Annarino. It's jacque.annarino@dot.ohio.gov. And on behalf of the OTEC committee, the Ohio Department of Transportation, and our presenters, thank you very much for joining us and enjoy the rest of your day.